Now you can go ahead with the different things as well. Okay, you can go ahead with the different things as well. You can you can simply use the duplicated as well. Okay, and you can use the company data set. Let's go and run this, and here you can see we got the output in terms of true false logical output we got, right? We got the output in the logical manner, right? Or okay, like if you just wanna remove the duplicates from your data set, and you wanna the data set, and in that data set only unique values are there. So how you can do this? You can simply okay, go ahead with your either your original data name, or like I did before, I can simply use any other data name. Let's say my df data frame, I can simply go with this df. Okay, so why I am creating this? This is just the name of the data set. Okay, nothing else. Okay, so I want my new data set, okay, which is having only unique values, okay, of my previous data set. So what I can do is I can simply use this, and I can use the unique method is there, right? So just by using unique method, I'll be adding my company's data set over here. See, and just use the control plus enter to run, and now here you can see this is my data frame. If you see, so basically I remove the duplicates from my data as well. Okay, I remove the duplicates from my data as well. Now you will see that basically there are two duplicated values, right? So we just remove this. Now the value is going to be the 16 because there are two duplicate values. Okay, so from overall 18 observations, if we remove the two duplicates, so basically we'll get the data of 16 observations, right? So that is the thing. Now okay, like if you wanted to find out the unique values by using like many times, okay, you don't want to go with this inbuilt functions. If you you just wanted to go ahead with any particular library, so for that what you can do is you can use the different libraries as well. Okay, and in R we have a very popular library which is nothing but the deep layer library. The deep layer library, let me show you. Okay, this particular library. Okay, the description for this deep layer library, which is nothing but a grammar of data manipulation. You see, a grammar of data manipulation. So here you can see the all about the grammar of data manipulation language, which is library, which is nothing but deep layer, right? So here you can see the many different things you can do. You can start by the apply function on across multiple columns. Sorry. So if you see that the second thing is you can add the columns as well. Okay, see, add columns, you can do multiple things. Okay, you can the count the observation in each group. Okay, then you can do filtering as well, right? You can do the filtering joins as well, you can see if you okay. So then you can sort your data as well, right? So you can sort your data as well, you if you see, right? Likewise you can do multiple things. Okay, if you wanted to explore more about deep layer library, you can simply go ahead and check this. Okay, if you wanted to go ahead this, okay, just go ahead and check this, right? Now okay, let us go ahead with this our thing. So for that, initially we can simply go ahead and use the deep layer library. Okay, initially we can simply import the deep layer library, right? So just import the deep layer library by using the library, and in the you know curve open bracket you can simply import it, right? See, I just imported it, and now after this what we can do, we can simply go ahead and apply a distinct function of my deep library, library on my company data set. Like I created the, the new data set, which is nothing but the df, right? And in the df there are no missing values, but in the company's data set we have the missing value. So now again let's use the company's data set instead of df. Okay, this is again to show you, for doing single things there are multiple ways. Okay, like many time, like if you see, like if you go with the, any, like if you go for any interview, okay, so at that time, okay, they are trying to, they want the answer not in a specific manner, they want the answer in the, they want the, multiple answers, right? Like this way also you can do it, this way also you can do it, right? And why you are going with this, why you are going with this, right? Like this. So if we going with this particular library, which means that, okay, it's a, the, good way, because you see that the inbuilt functions which are just defined by the R, right? But the deep layer library is the aim of this particular library. In the name itself you will see that it's a grammar of data manipulation. Okay, which means that it will, while you are working with a very big data set as well, so if you are using this deep layer library, it will give you the multiple data pre-processing functions. Okay, so then you can simply use this library for the data manipulation or the data pre-processing, data cleaning in short, right? So here what we are doing is we are simply using the, let's say, unique, we are just creating a new data set, unique companies we can simply say. Okay, because we are finding out the unique companies. Okay, now here you can use the, equal to, or you can use a alt plus hyphen. Okay, this particular symbol as well. If you see many a time, the, in R, people are used to apply this particular function, okay, while they are creating any this particular symbol instead of equal to, right? So they'll be using alt plus hyphen for this particular, to get this particular symbol in it, right? So now here we can do it, we have the distinct function for this. Okay, and here just use the company data set. So this is the one way, this is the one way to write your code. Okay, what is another way? What is another way? This is the one simple way, like we also, doing this all the things. But if you wanted to go ahead with another way, so you can simply use first your company name, okay, company data set, and then you will use percentage, okay, greater than symbol, then percentage. Okay, you will use this particular symbol to apply this, or you to create the, in short, the pipeline in R. Okay, like first what you are doing, okay, it's also easy to read your code as well. Like you are just uploading your data set, you are finding out the distinct values of your data set, right? After finding out the distinct value, you can apply any other function as well, you can apply any other function as well, you can find out the mean of your data set as well, you can find out the summary as well, right? But our aim here is to find out the unique values, right? So that's why we are doing it. So this is the thing. And to see the data, so you can see the unique companies are here, total 16 observations. If you wanted to see, you can see over here. See, this is my data. Okay, the company data set is there, right? So that's how you can simply go ahead with. Okay, like there are many different ways, guys, right, to find out this. Like if you wanted to go ahead and select the particular column, and if you wanted to check this, so here in the distinct column, okay, in the distinct column, if you see, like let me copy this particular code over here, so you will be able to, okay, you will also get this particular code, right? So you will understand this particular code. Okay, this is the thing. Now if you wanted to apply this particular function, this distinct function on your company data set, so you can, okay, like if you wanted to go ahead with singular particular column, so you can simply add the column name over here. Like in my company's data set, as we know, what are the different columns are there? So here if you see, what are the different columns are there? Account number, account name, status, gross income, like that we have the multiple columns. So let's go ahead with the, let's say, the account name, right? See, account name. Now here if you see, okay, what we are doing is, okay, we are just going with this and finding out the distinct value in this particular column. Okay, which means we are just finding out the distinct value for this particular column, right? So that's how you can go ahead and apply this thing on multiple, okay, like on like by using the multiple different ways, I can say. Okay, guys, do you know about the MySQL? Like we'll be learning that, like we'll be talking about that MySQL in the tomorrow's session, right? So if we're talking about the distinct, so like in MySQL we'll be using distinct to find out the unique values. So here also, like I mentioned, the, you know, the name for the data, unique companies, okay, which means that we are just finding out the unique companies from this particular data set, right? I'm just finding out the unique companies from this particular my company data set, right? Or in short, the, you know, the unique companies or distinct companies, right? So that is it. Okay, nothing else. Unique means distinct. Okay, different from any other. Okay. Now after this, guys, okay, let's see. Uh, let's say, like I mentioned previously, okay, like the data transformation. Okay, so which means that also known as a data scaling. Okay, so if we're talking about the data scaling, so like, okay, let me tell you one example, okay, about the data scaling. So like let's say, take one example of, let's say we have the multiple columns, okay, in my data set, and let's say one column in my data set which is nothing but the, we can say, the age. Okay, let's say we have the employees data set, and we have the employees data set, then we have the name, we have the age, employee ID is there, we have the address is there, the position of the employee is there, okay, the age column is there, the salary is there, right, of the employees. So likewise we have the several variables in my data set. So if we see the data set, so in your data set, let's just take the two columns, age and expected salary. Okay, just take the two example, the two columns from your data set. First one is nothing but the age, and second one is going to be the expected salary. So guys, what is the, you know, the common range of age? Like as we know, age starting with 0, newborn baby. Okay, then what is the upper level? Let's say 100. Okay, yeah, or let's go ahead with 80 or 100. Okay, so like Arif mentioned, 0 to 100. Okay, so let us go ahead with this. Now what is the range of salary, the employee salary? I am not mentioning any data set anywhere. So because we are talking about the example, that's why you can, yes, yearly salary, annually, right? So what is the salary of the employees? Let's say we have the data scientist. So what is the range of the salary of the data scientist? Let's say 7 to 11 LPA. So if we're talking about LPA, which means that 6-digit, okay, number, or if we're talking about 11 LPA, so that is nothing but a 7-digit number, right? So if we compare our age, which is nothing but the either 1 or 2 digit number, okay, and if we are comparing this with the 6 or 7 digit number, okay, and you are using these two same column, okay, to build the one model, right? You are using the age column as well as the salary column to build the one model, okay, which means that if you created the model, definitely your estimated or that particular salary column is going to be, your highest weightage column, which means that your model is totally biased towards your salary column because the range of the salary column is very high. Understood? So your range of your salary column is very high, so which means that model is just totally biased towards this particular column, and model definitely neglect the age column. Okay, if we're talking about the weightage is not same for both the columns. So to convert the unbiased data set, because of the weightage is not same for each and every column, so for we have to convert this particular data set, these particular two columns, okay, from, you know not same weightage to the same weightage columns, right? And then we can simply go ahead with the building the model. Then at that time, the model we are getting, which is unbiased one, right? Which is unbiased one. So for that, okay, what are the different data scaling method, data transformations method are there? So if we're talking about, okay, so basically we will be using the, the multiple methods, okay, like we have the standardized and we have the normalized method, right, for this. So let's see one of this, so for understanding purpose, okay. So for that, what I am doing, I can simply creating one simple data set, okay, one simple data set. Let me create the data, right? Not this particular data set, so let me go ahead with the new name, which is the D1, right? This is my data set, okay. Now after this, what I am doing, I can simply use the data dot frame, okay. Here you can see one function automatically pops up, and here if you see, okay, we'll be using the data dot frame. Now let's say my first column name is X, okay, and I am saying that, okay, like in that particular column, okay, I'll be taking a, the random numbers from the normal distribution. Like in R, to find out the random numbers, it's very easy. Just use the R norm, which means that just we are just taking the random normal numbers or random normal variables. Now for that, how many random numbers we want from the normal distribution? Let's say 10 values we want, okay. So then after that, we'll have to add the parameters of the normal distribution over here, okay. We'll have to add the parameters of the normal distribution over here. So let's say my mean of the normal distribution is going to be, let's say 30, right? And my standard deviation of this is going to be, let's say 20, okay. Or not 20, 20 will be, so much bigger. You will find that the variance is quite high, okay. So let's go ahead with the point 2, right? Point 2 is standard deviation is nothing but the variance is 0.2, okay. 0.2, which is nothing but a very small variance is that, okay. Now after this, let's create the new column, okay, Y column, which is a new column. And now let's take a random numbers from any other distribution, let's say uniform distribution. So for that, I'll be using the R for random, unif for the uniform distribution, right? So I'll be using this okay, R unif, and then here again I'll have to mention how many values I wanna find out, which is normal one. The minimum value or the parameter here, if you see in the uniform distribution, there are total two parameters. First one is minimum and second one is maximum. So the minimum range for these values will be like, let's say let's go ahead with 3, and let's go ahead with maximum value for this, let's say 5. Okay, this is my data frame. Let's go and create this data frame. Let's go and run this and see, this is my data frame. Okay, so this is my x value. In the x value you will see that the values, okay, which is around the 30, with the different, with the variance in that, which is nothing but 0.2, right? So that's why you will see that the difference, which is very less. Okay, like the 30.34, then 30.13, 29.99. If you increase this value, standard deviation, let's say by 2, so you will see that the range will also increase. You will see the values like the 28, 32, like this, which means variation is also high. Like after this, okay, this is my uniform distribution. Okay, which is the minimum range for uniform distribution. This is totally customized. Okay, this is a customized one. You can take any minimum value, either negative, positive, no matter. You can take any positive value, but like if you are taking the minimum value, we should be minimum to your maximum value. Let's say if you are taking your minimum value as a 10 and you are taking as your maximum value as the 8, which means that 10 is not minimum than 8, 10 is maximum than 8. So that's why, okay, we'll have to take the minimum value which is less than your maximum values. Okay, so okay, these things you will have to remember. So this is my data. Okay, you will find that the data is between 3 to 4. Okay, you never see the data which is outside the 3, minimum value 3 and maximum value 5. So you will always see this data y values will be in a, which is totally random, but these values will be in the range 3 to 5 because we mentioned the range minimum and maximum, and these are the two different parameters of the uniform distribution. Okay, and you see, like many times, okay, like for many different cases, sometimes client don't have the data to share with you. So at that time you will have to create your own data. Okay, you will have to go with the either survey or either simulation. You will have to go with and create your own data, because sometimes the problem will be very rare, let's say cancer. Okay, so if you wanna find out the, the data of the cancer patients, so it will be so difficult. You will find that, let's take a very rare cancer. Okay, like the cancer will be like someone got the cancer like in out of 1 million. So at that time to find out the patient data is very much difficult. It's very hard to find out. Okay, so to build or to do research for that, the medicine, to find out the medicine for that particular, the cancer, you will have to go with the research first. So for that, for doing the research, we need the data. So for creating the data, okay, we will need this kind of distributions, right? Depending upon the, like the first we'll have to find out the which kind of distribution cancer, that cancer data is following, right? So like for, okay, and then we can simply use this term, okay, r unif or r normal or r exponential, depending upon any other distribution which is there in the statistics. You can use any distribution, okay, and you can create the data like this that I created over here. Okay, so it's not like that, which means like client, like sometimes never give you the data, client only give you the problem statement. Okay, sometimes, not all the times. So which means that at that time you will have to collect your own data, right? So that is the thing. So for that we should know how we can generate the data. So that's how I generated my data. Okay, now I just wanted to go and do the, you know the data scaling, because if you see, this is my x data, the range of x data is between the, around 29 to 30. Okay, let's say 29 to 31. Okay, and the range of the y data is going to be the 3 to 5. Okay, so you see the tremendous difference between the ranges. Okay, so for that reason, we can simply go ahead and apply the scaling. Okay, scaling is nothing but the transforming your data into the same range. Okay, so let's say uh, just to show you, okay, I'm creating the the data to, or I can simply use this name as the scale data, right? This is my scale data. Okay, to avoid any confusion. Okay, so this is my scale data. Now I can simply use this scale, okay, this particular function, and here you can see, just put your data. Okay, just put your data. I'm just putting my data. Okay, and let's go and run this. And after this, here you will see, okay, we got the scale data. Okay, this is my scale data. Now can you tell me the difference between this particular my original data and the scale data? If you see, our original data is nothing but the range of x is in between 20, let's say 29 to 30, and the range of y is going to be the 3 to 5. But here in the scale data, okay, the range of x, is going to be -3 to +3. The same for the y. The range of y is also between -3 to +3, right? So which means that we just use this one simple word to convert my original data, right? So like it's not like that data is small, so which we can use this thing. It's not like that. If your data, let's say you have the millions of columns and all these things, right? If you wanted to transform your data into the single range, which is -3 to +3, also the range of the your standard normal distribution, so you can simply use this. This is also nothing but the one theorem in the statistics which is very popular, which is nothing but the central limit theorem, right? So see, basically just by using that theorem, this is just the, okay, the application of the theorem, central limit theorem. Okay, so here you can see that, okay, we have the two distribution. Okay, we have the two distribution, and if we apply the scale and we converted our data from any range. Okay, take any range, like here our range is nothing but the 29 to 30 and 3 to 5. Now you can free to take any range. You can take any range in thousands. Okay, you can take any range in lakhs or millions or billions, whatever it may be. Okay, you can take any minimum value, you can take any bigger maximum value, no matter. Okay, if you are using scale function, which means that definitely it will able to transform your data from, okay, in the range -3 to +3. Okay, that is the application, power of central limit theorem, right? And we can, in simple words, okay, the power of your data scaling, right? So that's how you can apply this thing over here, right? Now guys, uh, let us go ahead and understand the, let's say, our data visualization techniques. Okay, because these are the few things. Okay, there are a lot of things you can do, depends on your data, right? If you wanted to more explore about the data cleaning, data visual, data pre-processing, okay, for that you need to download your own data. Okay, let me tell you the few sites, like the open data is there, then we have the Kaggle is there, as well as you can simply data.government. You can take the data from the government's sites as well. Like that you can take the multiple data, right? You can use any, your data, you can use any data, okay, and try to clean that data. Okay, apply any different things, like try to find out the missing values, try to find out the outliers from the data, remove those outlier, or fill those outlier, depending upon your choice. Okay, it's totally, it's totally your choice to how you can clean your data. So that basically for building the model, right? So that is totally define your how your model is, right? Whether your model will be strong or poor model or moderate strong model, like that. Okay, depending upon the capabilities of your cleaning, okay, it will give you the model. Okay, you will see that the accuracy in the model. Okay, and see guys, this is the 80% of task. If you are working in the as a data scientist, and you got the the project from a very scratch, you created your own data. At that time you will have to work on your data at least 80%, 70 to 80% of your total data science project duration, right? To clean and pre-process your data. And next thing is to just apply the models, because we know that already the professionals created the algorithms, right? Right, they just created invented the algorithms of machine learning, deep learning, and now you are seeing the algorithms of the LLM models, you can see. So that is happen because of the transformer is again the one of the algorithm, right? So now if you are seeing the chat gpt and all, these are also the invented by the algorithms. Okay, you will find that. Okay, like if you see the example about the chat gpt, you will find that they took the around 45 trillion, you know 45 trillion, we can say that the gb of data, not the 45 trillion, 45 tb of data they took to train the gpt, which is nothing but our chat gpt, not the chat gpt 4. Okay, they are constantly improving the chat gpt 4, right? Which means like we are just adding any prompt in the chat gpt, which is our free version we are using. Okay, we all have the access to that. So we are using that free version, so they are giving us the free version not because you are using it free. Okay, just because they have to collect the data from you, like what kind of, like the data you are just putting over there in the chat gpt. So that data is nothing but the the gold, like them. Okay, gold for them. And they will be using that particular data to build their new models like the chat gpt plus, gpt-4, right? So that is the thing. So data is important, and pre-processing is again the very important part for this. Okay, and after that you will see that the very less part of the model building, right? The 15 to 20% of your overall data duration. Okay, now guys, uh, let us go ahead and understand the, let's say, our data visualization techniques. Okay, because these are the few things. Okay, there are a lot of things you can do, depends on your data, right? If you wanted to more explore about the data cleaning, data data pre-processing, okay, for that you need to download your own data. Okay, let me tell you the few sites, like the open data is there, then we have the kaggle is there, as well as you can simply data.government. You can take the data from the government's sites as well. Like that you can take the multiple data, right? You can use any your data, you can use any data. Okay, and try to clean that data. Okay, apply any different things, like try to find out the missing values, try to find out the outliers from the data, remove those outlier, or fill those outlier depending upon your choice. Okay, it's totally it's totally your choice to how you can clean your data. So that basically for building the model, right? So that is totally define your how your model is, right? Whether your model will be strong or poor model or moderate strong model, like that. Okay, depending upon the capabilities of your cleaning, okay, it will give you the model. Okay, you will see that the accuracy in the model. Okay, and see guys, this is the 80% of task. If you are working in the as a data scientist and you got the the project from a very scratch, you created your own data. At that time you will have to work on your data at least 80%, 70 to 80% of your total data science project duration, right? To clean and pre-process your data. And next thing is to just apply the models, because we know that already the professionals created the algorithms, right? Right, they just created, invented the algorithms of machine learning, deep learning, and now you are seeing the algorithms of the LLM models, you can see. So that is happen because of the transformer is again the one of the algorithm, right? So now if you are seeing the chat GPT and all, these are also the invented by the algorithms. Okay, you will find that. Okay, like if you see the example about the chat GPT, you will find that they took the around 45 trillion, you know 45 trillion, we can say that the GB of data, not the 45 trillion, 45 TB of data they took to train the GPT, which is nothing but our chat GPT, not the chat GPT 4. Okay, they are constantly improving the chat GPT 4, right? Which means like we are just adding any prompt in the chat GPT, which is our free version we are using. Okay, we all have the access to that. So we are using that free version, so they are giving us the free version not because you are using it free. Okay, just because they have to collect the data from you, like what kind of, like the data you are just putting over there in the chat GPT. So that data is nothing but the the gold, like them. Okay, gold for them. And they will be using that particular data to build their new models like the chat GPT plus, GPT-4, right? So that is the thing. So data is important, and pre-processing is again the very important part for this. Okay, and after that you will see that the very less part of the model building, right? The 15 to 20% of your overall data duration. Okay, now after this, okay, like let's say you clean your data. Let's say you got you okay, you just clean your data. Let's say this is my unique companies which are nothing but the clean data. Now how to you know download this data from here? How to download this data from here? So for downloading the data, we'll have to check the you know the we can say that the our working directory. So for that we can simply go ahead with, and we can see the get wd to see our working directory, present working directory. So let's go and run this, and here you can see my present working directory is this. Okay, this particular folder. Now what I can do, I can simply use, not I can simply use this particular term. Okay, which one? Just write, okay, dot csv, this one. I'll simply use the write dot csv, and I can simply use the unique companies, okay, data set, because I just wanted to download this data set from here. Because now this data is, let's consider totally clean data set. Okay, now I'll have to download this data set from the R. So for that I can simply use my clean data set. Okay, and here if you see, I can simply name it, like what kind, which name you want for this. So we can say that the clean, let's say, companies data dot csv. In which format we want? CSV format we want, because original data is in the CSV format. Okay, and now, okay, let's say here if you see, like in the unique companies data set, you will find that this particular column. Okay, this particular column as well. So okay, now we can simply go ahead with, and we are saying that the row dot names equal to false. We don't want it. Okay, we don't want it. So for that, we can simply go ahead and run this. Now here you can see this code is executed, right? Now let me go and show you that particular data, the clean company's data. This is my data. Here, this is my particular data. That is that we just clean. Right? See, this is the data. Basically, we initially we have the 22 columns. We just remove it. Okay, because the data is, a few data points which are missing. Then remaining the data is like this, right? That's how you can go ahead with, and you can do multiple things, multiple, seriously guys, like many things are there depending upon your data, the quality of your data, you can do the multiple things. Okay, so this is my data we just created, which is nothing but the clean one. Understood guys? This is how you can do the, data cleaning. Now let's move to the data visualization. Okay, now let us move to the data visualization, right? So for that, what I can do, I can simply use the comment for this data visualization. Okay, okay, yeah. By using which one? As we know, like we will be using the, data visualization here. If you see with the ggplot2, right? So we'll be using the ggplot2. Okay, and believe me guys, this library is so big. Okay, like if you wanted to see the library, so here you can see. Okay, let me show you ggplot2. Okay, this is the ggplot2. Now here if you see, okay, what it is saying, create elegant data visualizations using the grammar of graphics. Okay, using the grammar of graphics. So this is all we can do over here. Okay, use these multiple things. See, like later wise functions we have later wise. So imagine, okay, like so many functions, and if you combine these all the functions, so see, try to imagine how many plots we can draw. See, later wise functions we have, right? So we can do so many different things, okay, with this particular data visualization library, which is nothing but the ggplot2. Okay, like basically we'll be going with the, few things. Okay, so for that, okay, we'll be using this term, okay, AES, which is nothing but construct, okay, aesthetic mappings, because with the help of this we'll be able to get the data. Okay, but before that, okay, like many times if you wanted to install this ggplot library, so you can simply go over here in the packets. Okay, like I already installed this particular library, so there is no need to install it. But if you wanted to install this library, you can simply go over in the install. Okay, and you can put the name ggplot. Okay, to here you can see this is my ggplot library, if you see, and simply click to the install. Okay, and it will automatically install your library. Now the second thing is that you don't want to go with this option. Okay, this is the GUI, you know interface, we can simply say. Now if you wanted to install this, by the code, you can simply use this code, install dot packages. like if you see, this is nothing but the install dot packages we can, okay, we will be using, and in that just mention the ggplot2. Okay, that's it. Just run this particular line of code, and definitely, okay, this particular package will be installed by the RStudio. Okay, now for this, let me comment it out. Okay, so you can use this if you wanted to install this, right? So for that, I just comment this particular installation of the packages. Now let me go and import the library. For importing the library, I'll be using the library ggplot2. Let's go and enter this, which means run this particular line of code by using, either you can go and you choose the option over there, run, or you can use the control plus enter, right? Many times, like if you are a, let's say R shiny developer or a data scientist, that is like for, like if you are using a ggplot2, then many times, okay, like you will have to create the few line of code, write the few line of code at that time. Okay, like you should know how to run the code by using the keyboard as well. Okay, what are the different keywords are there to run the particular code, right? So that's why in, like in between, like the session, I'll be, telling you the things like how you can go ahead and run this, the your code by using the multiple ways, like either using the keyboard or simply use that particular option which is there, right? Okay, now guys, okay, we'll be using the another, we can say that the library, the data, not the library. Okay, so for that, as we know, we'll be using this particular data, which is nothing but the Titanic data for this particular topic, data visualization. So again, that this particular data which is already there in my getwd, which is nothing but my present working directory. See, this is the day6 folder, and in the day6 folder we have that particular Titan data set. So now simply go ahead and Titanic data set. Okay, so I don't want this capitalized word, right? So what I can do is I can simply use the Titanic name for the data. Okay, and then I'll be using the read dot csv. Okay, and inside it I can simply mention the name of my data. Okay, dot csv. Okay, and simply go and run this. Simply go and run this. Okay, now if you see in your data set, okay, let me show you the data which is nothing but the Titanic one. Okay, now for this, if you wanted to, if you wanted to clear your console, your plot, your all the history which is there in your environment, so you can simply do few things. You can go ahead in the console, you can use the control plus L. Okay, just use control plus L to clear your screen, because if you see that there are four different windows, right? So many times if you are not comfortable with all the data, which is all the code which is there, okay, like previous code is there, so that's why you can, if you wanted to remove that code or the, clear that code, you can simply go ahead and clear this, like, okay, see, now we just created all these three windows, right? Now what we are doing, again we are just importing this, and we are just, reading our Titanic data set. Now this is my Titanic data set. So in the Titanic data set, you will find columns are there in my, like in the previous data set. Now you can tell me yes. Okay, so if you see the columns, so first column is nothing but the passenger ID, then survive, then passenger class is there. Okay, 1 2 3, like, okay, the name of the passengers, you will see their gender, you will see then age. Okay, then you will see the many different things. Okay, the fare, cabin, ticket, like this. Okay, now, okay, let us go ahead and explore our data. Okay, so for that what we can do is we can simply uh, go ahead and we can simply use a summary, right? Okay, and we can use this Titanic data. Okay, let's go and enter this. Now here you can see that this is my summary of my data. Okay, this is the summary of my data. So if you see that we don't see any NA values. So okay, NA values in my data. Yes, there is NA value. Yes, see this, see total how many NA values are there? 177 NA values are there for the age. Okay, for the age, right, in the age particular column. And for remaining columns, I guess we don't have any missing values. Instead of those column which are character, those column which are character, right, we just find out the NA value present or not in the numeric column. Okay, but here in the with the help of summary code we can't find out the, you know, is there any missing values in the categorical column or not, right? So this is my summary. Okay, now let us go ahead with the, you know, the structure. Okay, structure of my data. So let's go and control and enter, and here you can see. Now if you see the P class, the passenger class, this type of this is going to be the integer. Okay, but if we see the type of this passenger class is going to be the factor one, the categorical one. Okay, factor is nothing but the labels are there, right? The labels are there. Okay, so okay, we will have to convert this into the factor. Okay, then we have the second column, let's say survive column. See again 0101. Okay, person is survived or not? 0101. Yes, in this term 01 you can say that it's integer, but okay, if you understand this data, so you will find that survive yes or no, which means yes, this is nothing but the categorical data, and we want this data as the factor data type, which means the data with the labels, right? The data with the labels. Now after that, if you see that the sex is again the character, male female male female, we want this data into the feature, the factor, which means that we want the labels for this. Again if you see the embark class, again you can see the different things, because we'll be applying our, you know, the data visualization by using, okay, many times you will see that we'll be using this column. So that's why I'll be applying the factor on these four columns. Okay, so let's go and okay, change this type of the data from integer or character to the factor, right? So let's go and simply use the Titanic. Okay, let's go ahead with our, let's say, first column, which is nothing but the survived. Okay, I'll be using the survived, alt and hyphen. Okay, press alt and hyphen as dot factor. Now I'll be converting it into the factor. This is nothing but the casting in Python. If you see, okay, like if you remember what we did in Python for the casting, casting is nothing but, okay, it's give us the permission to change the data type into the integer to character, right? So that's what we are doing over here. Okay, now guys, after this you will find that very beautiful plots will be there by using the ggplots. Okay, so now let us go as dot factor. Okay, I'll be using the same. Okay, Titanic dollar survive. Okay, now you can simply use this because we are just converting our four columns, okay, into this. So that's why we need this. Okay, this particular code. Okay, so that's why now for each and every time I can simply use another one, which is nothing but the, let's say, P class. Now here I just wanted to use the next one, let's say, which is nothing but the sex. I just wanted to change. Now I just wanted to update the embark column, right? This one. Okay, and what I'll do, I can simply make the changes. Okay, same for here as well. Okay, right? And for here as well. So this is the thing, just go and run it. Okay, and go and run, just simply go and run. Now if anyone wanted to see this particular thing, so let me show you why we change this. Okay, so for this, okay, let me show you the type for this. Okay, class of Titanic dollar survived. Let me go and run this. So if you see, this is nothing but the factor. If you see, this is nothing but the factor. And if you wanted to see the data, so again let me show you the data so you will understand. Okay, all the things. Now you will see that the data in 0 and 1, 0 and 1, 0 and 1, but in the end you will see that the labels. Okay, you will see that the label. Okay, this is because of we just converted this data into the factor. That's why you will see that the labels at the end. Okay, and this is the thing, label 0 1. Like for creating the data, as we know, like we need to define few questions. Okay, like on the basis of that we can say that yes, we need to see this. That's why we created this particular plot. Like, so if you wanted to see the like what was the survivor rate, okay, in that particular incident, in the Titanic incident. So let's say what was the survival rate. Okay, so for understanding this, let me just comment it out for because this is a just the question. Now we are just applying this. You can print anything, you can print anything, you can go ahead with p class and all. Okay, you will again find the same thing. Okay, nothing else. See, if you go and print the p class, you will see the levels 1 2 3, right? You can check by yourself as well if you want. Okay, definitely you will get the same output. Okay, now if you wanted to check the survival rate, okay, you will have to create the bar plot of the survival data, the survived data, right? So that's why I made the changes in the survived column, right? Now for that I'll be using the ggplot. Okay, ggplot, here I'll be adding the Titanic data, right? And here I'll be using this, right, AES. Now what does this mean? AES is going to be the the construct aesthetic mapping, right? So that's why we are using it. So basically in that we can simply use my first axis, which is nothing but the x-axis, because here if you see, okay, we are trying to visualize this all in the 2 dimension, right? So that's why x-axis I want the survived. Okay, I want the survived. Now here what kind of plot I want? I want the you know the geom AB line. I want area plot or bar plot. See, there are many options. If you see, so many options are there, right? So here I want the bar plot. Let's go and run this and simply run this small line of code. Okay, if you run this particular small line of code, okay, let me go and run this. Okay, what is the yes. Okay, now here you can see. Okay, sometimes it might it may take few minutes. Okay, so if you see that, okay, this is my plot. Okay, now you are saying that this is just a simple plot we just plotted on the like in the Python as well. Okay, so if you see, okay, behind this there are a lot of different things. Okay, you will see that the the lines are there. Okay, grid lines you can say. Okay, the labels are here, survived, count, right? Like if you wanted to upgrade this, customize this, okay, by yourself, okay, so you can add the labels, you can add the theme to your plot as well. Okay, let me show you. You can add the title as well to your plot. Okay, but what, okay, what was our question? What was the survival rate? If you really want to see the survival rate, you know survival rate into the percentage, then you can simply use this particular line of code. Okay, the proportion table, use these, and in that just use the table and just apply it on the, okay, Titanic dollar my survive data. Okay, and here you can see the exact percentage of the survive rate. Okay, you will see that the zero means mortality rate, this is the survive rate, right? So 0.38, which means 38 out of 100 passengers, only 38 passengers survived, right? If you're talking about this range, so out of 100 passengers, only 38 passengers survived. Okay, and the mortality rate will be like 62 passengers, okay, died. So this is the thing, this is how you can go ahead with. Now if you wanted to customize your plot, okay, so let me copy this and use it over here. Okay, now what I can do is I can simply add the few terms. Okay, I can use the, I can add this particular term, which is nothing but the complete theme. Okay, complete theme. If you see, I'll go with the default value. I don't want to go with the parameters, because you will see that for each and every option there are lot of parameters, right? Then third one, I'll just have to add the labels. So that's why I can simply use the label. So you can see that here okay, it will give me the permission to modify axis, legends, and plot label. So if you see this, all the things, so this is the advantage of the Python R Studio, because you will see that each and every time, okay, in the blue label, you will see that in the blue pop-up will be automatically come over then, and it will guide you like, now you will have to add this, you will have to add this, you will have to add this. Okay, now I'm just saying, just add the the y-axis label. I want the label as the passenger count. Okay, now I want the title. Okay, now what kind of title I want? Let's say Titanic. Okay, survival count, right? This count, or you can say that the survival rate. Okay, we can simply go ahead with. So let's go and run this, and here you can see more proper way. In a more proper way, if you wanted to zoom it, you can simply zoom, and you can see in the new window, this is your plot. Okay, with the the title over here, the X label, Y label, you can see over here, right? You can do like this, you can do so many different things. See, you can do so many different things. Now after this, like let me ask you another question related to this particular. Now what was the survival rate by gender? Like, I just wanted to check the gender wise survival rate. Okay, so let me just copy this again, because the question is again bit similar. Okay, survival rate by gender, that is nothing but the sex in this particular problem. Okay, so let me go and run this. Okay, so now here all the code is same, all the code is same. If you see the Titanic data we are using, we are on the x-axis. Now we want the our gender, and here gender is going to be the sex, right? Then second thing is that, okay, I just wanted to fill all these, okay, because we want to check the survival rate na. So that's why I'll go and fill these, okay, by the survived, right? Second things, I'll go with the same line of code, okay, but here I'll just update this particular title, because now this is going to be the survival rate by gender, right? Okay, let me go and run these, and now here you can see, now this is the plot, right? So here you just fill the, in the six, like the female and male, if you able to see that. Okay, let me just small, just change the size of this. Okay, so if you see that here the female, the male, so if you see the survival rate of male is very high as compared to the survival rate of female. Okay, so actually, like, my bad. So here if you see the survival rate, so which is nothing but a zero. Zero is for mortality, okay, and one is for survived. So which means that if you compare this male and female by the gender, so you will see that the survival rate of the female is high, okay, as compared to male. Okay, because you will see that the, the, priority is there. Okay, like everyone wants to, protect her female, right? So that is the thing. So that's why you will see that the, the survival rate of the female is, high, and the survival rate of the male is low. So you will see that the mortality rate of the male are very high, which is quite high as compared to the mortality rate of the female, right? So that is the thing over, and that's how you can, uh, read this particular plot. Okay, so like you can do multiple things with this. Okay, you can do multiple things with this. You can go ahead and you can, do, different things. You can check the, what was the survival rate by the class of the ticket, right? So if you wanted to check this, so you can again use the same thing. Okay, you can again use the same thing. You can just copy and paste this, like, let's say if what was the survival rate, okay, by the class of passengers. Okay, so here instead of the sex, what I'll be using, I'll be using the passenger class, right? I'll be using the P class, isn't it? And the rest of the code, you know code will be same, but here the survival rate by the, P class or the class of passenger, I can simply copy this from here, right? This is the thing only. You can simply go and run this, and now here you can see. Okay, again the very, interesting plot you will be able to see. Okay, now if you see the passenger class 1 2 3, okay, 3 is okay, which is nothing but the highest class, I would say. Okay, so if you see that the 1 2 3, okay, so there are three different classes. Okay, higher class, middle class, like this, or like depending upon that particular situation, first class, second class, third class, if you see. So the mortality rate for the third class is very high, if you see. Okay, and the, the if you compare the survival rate by the class of the passenger, so you will see that the survival rate of the class 1 passenger, okay, is higher than any other class of passenger, if you see over here. And the mortality rate is also low. See, mortality rate is also low. Here you can see that the, second class passengers as, are less, very less, we can say, as compared to the both classes. So it's like the 50-50%. Okay, and in the third class you will see that the mortality rate is very high and the survival rate is very low, right? But it's again more than the survival rate of the class 2. Okay, so that's how you can read the plot, right? And you can understand the many different things by the plot, that you can't understand it by the numbers, right? So if you just plot this, so you can like easily understand this. Yes, right? So like that you can go ahead and you can use any different things. Okay, you can apply this all the things, see, ggplot is very high. Okay, like if you see that the documentation, you will find that a lot of things are there. Okay, so if you go and explore this all the things, which means that okay, we need to create a separate course for this, right, for ggplot only, because you will see that the lot of things are there. Okay, so my suggestion is to go ahead and explore the multiple things, like how you can do the multiple plots, right? How you can create the any different plots, like I created now here the bar plot. Okay, now how you can create the different plot, like how you can create, let's say like I created the bar plot. Now how you can create the ribbon and area plots, how you can create the heat map, how you can create the heat map in 2 dimension. If you wanted to go ahead and if you wanted to, this is the alternate way to create the bar chart again, like we created here by using the geom bar, right? So you can create this by using the geom column as well, right? Then how you can go ahead and find out the create the contour plot, right? So likewise you will see that the so many plots are there. Okay, just try to explore as many as possible, right? Now after this, okay, let's go ahead with our further topic. Okay, which is nothing but the basic statistics. What are the basic statistics we can simply do? So in the basic statistics, if you see, like there is a central movement is there. Okay, central movement is nothing but the mean, median, mode. We can just simply find out, right? So as we know, like how to find out the mean, median, mode, right? Mode is nothing but the most frequent value. So how to find it? We know that in the R studio. We know the how to find out the mean, how to find out the median, right? Then we know how to find out the standard deviation. Okay, like I can simply write this thing over here so you will understand. Basic statistics. Okay, so we know how to find out the mean. Okay, we can simply find out the mean of, let's say, Titanic dollar. Okay, uh, age. You can find out the mean of the age. uh, you know no, here we got the any value. Why? Yes, so might be sometimes if the any value present, like as I told you, the any value are there. Okay, in this particular data, so you'll find out that age. So that's why you will see the any value is there. If you wanted to see, let's say, fair. So let me show you the mean for this. See, mean for the fair is going to be around $32. Okay, at that time, right? If you wanted to find out the median, you can do the same thing. Okay, Titanic dollar, again we can use the fair over here. Okay, so you will see that again the median price for this is going to be the you know we can say that the $14. Okay, now okay, like there are multiple ways to go ahead with. Now we can find out the, let's say, we can find out the mode, or we can even find out the the variance. We can find out the standard deviation, right? So okay, okay, okay. Okay, because we are implementing mode on the any categorical data. So I guess we'll be using that particular thing on the let's say any column. Which column we just wanted to go ahead with? I guess let us go ahead with any column which is character, the mode. Okay, so what we can do is we just go ahead with the sex. Okay, or we can simply go ahead with the survived or p class. Okay, can. Okay, so like there is no proper function for this to find out the mode. Okay, so you can see that. Okay, this is the type of a this is a storage mode. Okay, so now fair. Now we can simply create the function for this. Okay, we will have to create the function for this. So for creating the function, okay, we should know how the mode is nothing but the most frequent value. Okay, so here if you see, we can simply go ahead with like, okay, mm, like let's say get mode. Okay, we can create the function of let's say function of v, or we can you can go ahead with whatever like x and all, right? Then we are checking the unique values. Okay, the unique values for this. So for that we'll be using again unique function of x. After this, okay, we'll be using this, okay, unique, this particular function that we created above. Okay, and in that we'll be checking that which, okay, like which particular the values which are there, which are having a very high value. Okay, which is repeated maximum number of time. Okay, so that's why I'll be using a tabulate. Okay, in the bracket, if you see that we are trying to match the you know our the data, which is nothing but the v. This is not the x, this is the v. Okay, like you will have to use only one letter if you go ahead. Okay, and unique. Okay, uh, you can simply use a unique because we just created this thing over here. Okay, just to avoid confusion, we can simply use the unique as well, like if you want, like this unique. See, because these two terms, this is the function in R, and if we use the same thing, like it might sometimes it might be confusing, right? So let's go and run this. Okay, so we just created the function. Okay, so at that time, see, v is not found, but like after creating the function, okay, like we'll be using the get mode. Okay, get mode, we just created the function. Okay, and now what we are saying is just find out, let's say uh, uh, the mode for the you know 6. Okay, dollar. Okay, now let me go and run this again. I'll have to run this thing. Yeah, and let me go and run this. I guess few things which are not matching. Yeah. Okay. Like the one more thing, like as we know, okay, if you're talking about the mode, which means that we have to find out the maximum number of time that particular value repeated. So here we'll have to add the which dot maximum value. Okay, then it is capable to get the mode. Okay, now see, mm, like simply get out of from this browse one. Okay, and let me go and run this, and now here you go, let's go and run this. Okay, get mode, table is missing, I guess. Mm, okay, I guess. Okay, let us go ahead with the survive. for now. Okay, and let me go and run this. Why it is, making this thing? Okay, and if we go with this, okay, I think some uh, issues with this. Okay, yeah. Yes, we'll have to convert this particular thing into string to numerical. Then it will take, because if you see over here is you know like we'll have to convert this from string to integer. So what I can do is I can simply use these. Okay, instead of using this, we can simply use any numerical value, right? Then simply use this sib sp. Okay, sib, I guess, which one? Okay, sib sp. So then simply use this sib sp, and let's go and run this. It's on the browser, my bad. Okay, now here I guess it might work. Okay, no worry, we'll figure it out, I guess. Okay, so after this, okay, you can find out the variance for this. For that we'll have to, okay, we'll check the numerical value I guess, because all the data is quite we'll go and find out the variable for variance for this particular fair. Okay, variance is nothing but the variability in your data, right? So for that you can go ahead and use these, okay, and see the fair. Okay, and you can find out the variance for this, right? After this, uh, like if you wanted to find out the standard deviation, okay, so you can use this SD, and again use the same thing. Okay, Titanic dollar, the fair one. You can go ahead with and run this. See the, again you can see the standard deviation. So you can do the so many different things, which means, okay, you know these are nothing but the basic statistics. You can find out the mean, median, mode, you can find out the variance, standard deviation, and so many different things, right? Now what about next? Like, let me show you how you can do the advanced statistics, which means how you can go ahead and find out the some regression, ANOVA, analysis of variance, right? So for that, okay, like as we took the one data set, which is nothing but the WC80 data set, our the simple linear regression data set, that data set I'm gonna use over here as well. So for that, okay, let me go and basically use this particular data. Okay, WC80 data set, I'm gonna saying that read.csv. Okay, and then I'll be using this particular data, which is nothing but the, over here if you see in the data set, which is nothing but the WC80 data set, and I'll be using this particular data set. Okay, now just use the WC, okay, 80 data set over here. Okay, dot CSV. Okay, and simply run this. Okay, as we know, this is my data, and in my data there are two column, waist column and 80 column. Okay, so on the basis of waist circumference, I'll have to find out the model which can predict the 80 adipose tissue data set. As we discussed this all the thing, this problem statement in the previous session. Okay, so that's why I'll be using this particular same thing over here, right? So we can simply go ahead and simply, as we know, we did the multiple things over there, like we find out with the summary of the data. We plotted this several plots, like the histogram box plot we plotted. But for now, what we can do, we can simply go ahead and simply build the regression model, right? To just show you how you can build the regression model, how you can do the advanced statistics in R as well. So for that, we have the one basic method for this. Just go ahead with and put the name, okay, for the regression, and use the LM is stands for the linear models over here, right? So now, okay, we can simply go ahead with and use our data set, okay, WCAT, okay. Like there is another way as well, let me show you the one way, okay. We have the one method which is nothing but the attach, okay. If you know this method attach, which means that you can simply use the column names instead of mentioning the data name, okay. So what I can do is I can simply use the WCAT, and just by running this, okay, it will be, now I can able to use the column name instead of the, like the first I'll have to mention the data, then dollar, then that particular column name. Instead of this, I can simply use the column name now. So 80 is my one column, and you know then we have another column which is nothing but the waste column, right? Comma my data, okay. So because we use this particular term over here attached, so now no need to use any data and all. So because, okay, now it is automatically taking this data set, okay, from this, these columns from this particular data set, right? So that's why simply use this term and go and run this, right? Now after this, use the summary, okay. And if you know the summary, so you can simply go ahead and apply the regression. Now you can see the summary of my model. Now as we know, okay, there are few different things, okay. In Python, we got the summary in terms of first the evaluation matrices, then we got the summary. This is my second table in Python. Okay, as we know, the t value are there, the p value of the t tests are there. Okay, so we can say that just by here looking at this particular thing, we can say that, okay, our column, each and every column which is there, which is the significant column, because the p value which is again very much less, okay, 2 into e raised to minus 16, which means that it's very much close to 0, right? Like if you wanted to see the code of the significance over here, so you can simply see the code of the significance. See, if we have the only one star, we also say that this particular column is the significant column, right? But here we have the 3 star, which means that the column is very much significant, right? The column is very much significant. Okay, that's the the good way to understand this thing by using the significance code over here. Now the second thing is that if you see the R square, okay, as we know, we got the R square over there around 67%. Here also we got the same R square, which is the 67%. Okay, adjusted R square is nothing but the 66.7%, if you see, right? Then this is F statistics is nothing but your analysis of variance. If you wanted to cross check, what you can do is, okay, we can simply go and check this. Okay, we can simply go and use ANOVA, okay, analysis of variance over here, okay. And basically with the help of analysis of variance, what we are checking, we are just checking the significance of my overall model, okay, here, because we are applying the whether the one particular column or the multiple columns, okay, depending upon the data, okay. Here we have only one independent column, one dependent column, so that's why we can simply say that, okay, we can simply go ahead with the single term as well. But if you have the multiple data, multiple columns in your data set, so you can go ahead with the ANOVA, and you can see that whether your model is significant for making your further prediction or not. So you can check it like this, okay. So if you see over here, okay, in the regression output, okay, you will get the ANOVA value, the F statistic, direct the final result you will see, and the p value for that. So here also, okay, this is the explained solution, I can say, okay, explained solution of the analysis of variance, which means that you can understand the different terms. Like someone asked me in the previous session how you calculate the R square, right? So the formula for calculating the R square, which is nothing but 1 minus sum of square due to residual divided by sum of square due to total, right? So here you can see that we got the sum of square due to residual. Okay, sum of square due to residual we got, and if you add these two value, this value and this value, you will get the sum of square due to total. Okay, now you got the two value and you can simply find out the R square. You will get the same result if you wanted to check. See, okay, and if you wanted to check this F statistics, you can see the F statistics over here. Okay, if you see this thing 217.3 and this 217.28, if you round this to one decimal point, you will get the three value 2.17 point 217.3 value, and the p value is again same. See, the p value is less than 2.2 into e raised to minus 16, so again the same value. Okay, this 3 star means, okay, your model is significant. Okay, your model is significant. So behind this there is one hypothesis testing. Okay, is that, which is saying that in the null hypothesis you can say that the your model is significant, and in the alternative hypothesis you can say that your model is not significant. So you can simply use it and you can say that your model is significant like this. Okay, so that's how you can apply the, you know, the analysis of variance on that, right? Like we'll be talking about the, you know, the mode in the upcoming we can say that the tomorrow's session, right? Okay, so thank you guys, thank you very much.